And is your exam on the entire organic chemistry chapter or just a few topics?
No, 1 second, let me tell you exactly. It is till it's carbonyl carbons last
Carbonyl
till
compound.
carbonyl carbon.
Till carbonyl compounds.
Oh wait. How should I explain this to you? Because he has like his own set of notes and stuff.
Okay. So what we can do is we can start with some topicals like we can. Did you do alcohols?
So should I tell you what alcohols? Yeah, I think we've done alcohols.
Your test is on alcohols, right? So first one.
No, sure. We have hydroxy.
Hydroxy is alcohols.
Yeah, we've got halogenalkanes, alkanes, alkenes, carbonyl carbons, compounds. I mean, sorry.
Okay, so let's start with alcohols. Okay. So anything that we haven't done, we'll just go through that. I'm just assuming everyone has notes for organic chemistry, so we'll be focusing on these questions. So first one is I have this board open as well. Just 1 second. So 5:45, yes. I said this one. So let's just focus on these alcohols. We've got primary, secondary, and tertiary alcohols. So first thing, I'll just quickly go through that. There are 3 types of alcohols. Primary alcohols are one which have just one carbon chain. It's got one carbon chain, and on 2 sides there are hydrogens. Secondary one is that it's going to have 2 carbon chains. There's only going to be 1 H and there's going to be 1 OH. And a tertiary alcohol is that the alcohol group, this is known as the alpha carbon. Alpha carbon is the carbon, you refer it to as the alpha carbon. It's the carbon on which the functional group is present. So that particular carbon would be on 3 sides bonded to carbon chains. So that's the concept of primary, secondary, and tertiary alcohols. So starting with this one, we have in this question over here, you're given so which one is your primary alcohol, which one is your secondary, which one is your tertiary alcohol? Can anyone guess what's the right one? Is this primary or secondary or tertiary? What particular alcohol is this one?
Primary.
Okay, so that one is primary. Like if you open it, the carbon has 2 H's bonded to it, and it only has it's got CH2OH, and it's got 1 carbon chain, which is CH2CH3. So it's only got 1 carbon chain that's attached to it, this particular carbon atom. So which is why it's a primary alcohol. What about this one? Is this primary or secondary or tertiary? Which one is this?
It's both primary and secondary.
Okay, the first one is primary. The second one is secondary because this carbon, the one I'm marking, that's attached on 2 sides by a carbon chain. So that's a secondary, but the first one is a primary because the first one over here has only one carbon chain. So it's both primary and secondary. Is there any tertiary alcohol in this one? Which one is this one?
The first and last carbon atoms are primary. The middle one is tertiary. Secondary.
The middle one is secondary. So the middle one has 2 carbon chains attached, one on top, one at the bottom. So there's 1 H. So there's no tertiary alcohol. So which one is the correct answer? What about the last one over here? Is this primary? It is primary, right? It's got 1 carbon chain. This one, the one that has OH, it's got 2 carbon chains. This one has 3 carbon chains that are attached to it. So the first one is primary, then secondary, then there is tertiary. Is that clear?
Yes.
So then the next one is about an organic compound will decolorize dilute acidified potassium magnate 7 on warming, but will not decolorize bromine water. What could be the organic product? So first thing, very, very quickly, let's talk about the oxidation of alcohols. You've got, in the last class, we did the oxidation of, I think, alkenes, where I told you that alkenes undergo strong oxidation. We did some example, alkenes undergo mild oxidation, they undergo strong oxidation. Now we're going to just quickly discuss what will happen to alcohols. Alcohols, they have oxidation as well. They've got primary alcohols will be converted into, so primary alcohols, what will they be converted into? They'll be converted into, just give me 1 second. So primary alcohols, they are going to be converted into aldehydes if you oxidize them. And those aldehydes will further get oxidized to carboxylic acids. If the reaction does not stop at that point, they will get further oxidized into carboxylic acids. The conditions required for that is, remember, primary alcohol is what? It's a carbon with one OH and one carbon chain. Now, this particular carbon atom would turn into an aldehyde. And then it will further get oxidized to a carboxylic acid. So all the changes that happen, they happen to this carbon atom. The one that was an alcohol, it turns into an aldehyde, it turns into a carboxylic acid. What are the reagents that are required for oxidation? You need acidified K2Cr2O7 and reflux. That's number one. The color change that happens when you use that is orange to green. The other one that you can use but not recommended is acidified KMNO4. It's so you can use that as well, and that would also require reflux. What is reflux? You put a condenser on top so that nothing can escape, and the color change in that case would be purple to colorless. Anyways, you can use the same two reagents for the next step as well. Remember, the reaction is not stopping at an aldehyde, but what if your starting point is an aldehyde? So you can kind of do the same thing for aldehydes as well. The same reagents could be used for aldehydes, but there are two other reagents that could also be used. There's one that's called Tollens reagent. So Tollens is silver with ammonia. It's silver dissolved in ammonia, which is so it forms this particular complex, and this also oxidizes aldehydes to carboxylic acid, and the result is that silver mirror or black precipitate is produced. Silver mirror is produced because Ag ions are reduced to Ag, which is silver, which is why you see. So what Tollens does is it oxidizes aldehydes, gets reduced itself. And there's another one, which is Felling's reagent, which is basically, it contains copper 2+ ions. It's a blue solution, and it produces a brick red precipitate of copper 1 oxide. Because again, it gets reduced. It oxidizes the aldehyde, but gets reduced itself. So that is the oxidation of primary alcohols. Secondary alcohols kind of they have similar reaction, except they don't turn into aldehydes. They turn into ketones. So yes, Hamza.
Sir, would Ideofoam test work for this example?
Then I'll talk about the Ideofoam test as well.
Okay.
So secondary alcohol. What's a secondary alcohol? It's secondary alcohol will have will have 2 carbon chains. So it's going to have another carbon chain over here. And that will turn into a ketone. Is that clear?
Yes, sir. Yeah.
And tertiary alcohols don't get oxidized. So tertiary alcohols don't undergo oxidation. So this is something that's very important. Primary alcohols turning into aldehydes, aldehydes turning into carboxylic acid, secondary alcohols turning into ketones, tertiary alcohols not getting oxidized. And then there's the reverse as well. You can do the opposite as well. You can reduce as well. So reduction will happen, reduction will happen. For reduction, the reagent is LiAlH4. For carboxylic acid, it's LiLH4. For aldehydes, it could be LiLH4 or it could also be NaBH4. And then you have ketones. Ketones can also be reduced, and the reagent would be LiLH4 or NaBH4. So this chart is really important. And I'll talk about the Ideofoam test. What the Ideofoam test is, that the Ideofoam test is not an oxidation reaction. It is an oxidation reaction. It's a redox reaction, but it's got nothing to do with this thing. Just 1 second. So I'll just briefly mention the Ideofoam test. Now, the Ideofoam test has nothing to do with what we just studied. The Ideofoam test identifies 2 structures. The reagents are NaOH aqueous plus iodine or alkaline iodine. It is used to identify this structure, which is specifically a methyl with a serial bond O. And over here, you're going to have a carbon chain or an H. Or it will help you identify this structure, which is OH and H. And over here, there's going to be a carbon chain or an H. So it specifically identifies these structures. Either this one, or it's going to help you identify this one. A methyl group with a serial bond O or a methyl group with CHOH. If this structure is present, the Ideofoam test, what it would do is that when you heat it with or react it with NaOH aqueous and iodine, in both cases, the CH3 breaks off, both of them. And it turns into a yellow precipitate of CHI3. And the remaining molecule over here, it turns into a carboxylic acid. It's whatever the carbon chain or H is. This particular carbon atom, it turns into a carboxylic acid, gets oxidized into a carboxylic acid. So it forms double bond OH. But since the conditions are alkaline, there's an NaOH there. Instead, you're going to get a salt of the carboxylic acid. So you're not going to get the carboxylic acid because the conditions are alkaline. So the alkali ends up reacts with the carboxylic acid, forming a salt. So that's what the Ideofoam test is. So the Ideofoam test is for 2 specific structures. They got to be there. Is that clear?
Yes, sir.
Yes.
Yeah.
So coming back to the question, he's saying that it will not decolorize bromine water. So that means it's what group is not present?
Alkene.
Okay, so
Alkene.
so that means it's not an alkene. So alkene is out of the question. So the remaining one is so ethene is gone. Carboxylic acids don't get oxidized. We just drew it on the table that the oxidation kind of stops at carboxylic acids. There are actually 2 carboxylic acids that do get oxidized. And let me just quickly check in the new syllabus, is this in AS or A2? There's just 2 carboxylic acids that do get oxidized. Otherwise, carboxylic acids don't get oxidized. Just one second. Where's carboxylic? That's this one. So this reaction of alkyl benzene with hot alkaline KMNO4. So that's in A2, I think. That is A2, 33.1. That's not in AS. It's not in AS. So in your case, you just have to remember up till this point that carboxylic acids, they're not going to get oxidized. And they don't. Only 2 of them they get oxidized. That's about it. But that's not in your course at the moment. Now coming back to the question. Where's the question? Hydroxyl compounds. So it can't be ethanoic acid. So the only option left is ethanol. That's a primary alcohol. So that's a primary alcohol. Ethanol. So what will it get oxidized to?
Ethanol.
And then it will turn into, so it's going to turn, I mean, it's everything would happen to this carbon atom. So it will turn into ethanol first, and then it will turn into a carboxylic acid. So the same carbon would turn into acetyl bond ON, OH. So that's going to be the oxidation reaction. So remember, the reaction usually does not stop at aldehydes. But if you want to stop the reaction at aldehydes, you got to change something. The reaction will not stop, but if you want to stop at aldehydes, then use distillation instead of reflux. I mean, change the conditions. And if you want the reaction to not proceed further, use distillation instead of reflux. Now, the logic behind that is, hopefully everyone knows what reflux is, but I'll just, and this probably doesn't work. Reflux heating. So maybe the internet is working. Now this is what a reflux is, or heating with reflux is. This is it. No, he's still stuck. Actually, anyways, I'll just tell you this. This is an opening. I'll just tell you, heating with reflux says this diagram is big enough, I think, that you heat a substance that is volatile. So if you heat a substance that is volatile, it evaporates very quickly. So there's no purpose of heating it because it's going to evaporate and it would escape the container. So you put a condenser on top. So it's a cold condenser with cold water in, cold water out. So any vapor that forms, it falls back into the container. You don't want the substance to evaporate. So you want to heat it. So alcohols are very volatile. If you know alcohols like the alcohol swabs that he put on your injuries, it's very volatile. It evaporates very quickly. So the condenser on top prevents that. So that means nothing can escape the container. So that's known as heat with reflux. Nothing would be able to escape. So if the primary alcohol turns into aldehyde, the aldehyde will not be able to escape the container. It will eventually turn into a carboxylic acid. And if you want to stop at aldehydes, what you're going to do is you're going to use distillation instead. Now, distillation is this thing. If you can see the diagram on the left, distillation is this thing. In this thing, you allow the vapor to escape and you collect the vapor in some other container. So in this case, in distillation, you are allowing the vapor to escape. So as soon as the aldehyde would be formed, the aldehyde would evaporate and they would escape and they would be collected at the other end. So you would immediately separate the aldehyde from the rest of the mixture. Is the idea clear?
Yes, yes.
Okay, so you need to distill it because reflux, nothing can come out of the container. Distillation, as soon as aldehydes are formed. And why would aldehydes escape? Because primary alcohols, they have asked this question as well, that why does distillation form aldehydes? The reason is that aldehydes have lower boiling points compared to primary alcohols as well as carboxylic acids. Why? Because they have OH group. This one also has OH group, so they can form hydrogen bonds. Whereas aldehyde does not form hydrogen bonds. So aldehydes have lower boiling points. So the reason this works is that aldehydes don't form hydrogen bonds. So they don't form hydrogen bonds like your like alcohols or carboxylic acids. Or carboxylic acids. So they evaporate more easily. So you can collect them at the other side more easily. So as soon as they are formed, you can just take them out of the container. As soon as they are formed, distillation will happen, and the aldehyde, which have lower boiling points, they would immediately evaporate, and you can collect them on the other side. Is that clear?
Yes.
Yes.
Okay, just remember they've actually asked you this. Why does distillation produce aldehyde? So you have to give the reason, and you have to link this up with the hydrogen bonding. Now the next question quickly. Which alcohols on oxidation with potassium dichromate 6 will cause an effervescence when reacted with carbonate, sodium carbonate? So that's a carboxylic acids are the only acids that you've studied. So they're the ones that are going to react with carbonates to produce, hopefully everyone knows this, acid plus carbonate produces salt, water, and carbon dioxide. So carbon dioxide is the one that's going to produce the effervescence. Is that clear?
Yeah.
Yes.
Okay, so carbonates, so that means whatever oxidation is happening, you're getting a carboxylic acid. So that means, is it a primary alcohol that is getting oxidized, or is it a secondary, or is it a tertiary alcohol? Who makes carboxylic acids when they react with potassium dichromate 6?
First,
So it's
First degree alcohol.
primary.
Primary. Yeah.
primary, okay. So that's a primary alcohol. Secondary alcohols don't form carboxylic acids, and tertiary alcohols don't get oxidized in the first place. So the only one that's possibly going to form carboxylic acids that will react with carbonates, that is a primary alcohol. So what about butane 1-ol? Is that butane 1-ol? So that one is 4 carbon atoms, and 1-ol means OH over here. And these are all H atoms. So is this a primary alcohol, secondary, or tertiary? What is this?
Yes.
So that's a primary alcohol, right? So that will turn into butanoic acid. This carbon would turn into butanoic acid. So that is fine. What about this one? 2-methyl propane 1-ol, the second one. So prop is 3 carbon atoms, 1-ol. So propane 1-ol first. OH on the first one. And on the second, there's a methyl group. So the second carbon, there's a methyl group, which will have 3 H's. This will also have 3 H's. This one will have 1 H. This one will have 2 H's, right? What alcohol is this? Primary or secondary or tertiary?
Primary.
Primary.
Okay, so you have to look at this carbon atom. It's only on one side is bonded to a carbon chain. So that is a primary alcohol. So that will also form a carboxylic acid. What about 2-methyl propane 2-ol? That means prop 2-methyl. So that means carbon on the, and there's OH, 2-ol. So OH is on the second one. Propane 2-ol, OH is on the second one. Methyl is also on the second one. The rest are all hydrogen. So is this what? Primary, secondary.
Tertiary.
So this one is a tertiary. This is not going to get oxidized. So it's never going to form a carboxylic acid. So the first two are the right options. The next one is you've got a compound hex-3-ene 1-ol P has a strong leafy smell of newly cut grass and is used in perfumery. What is produced when P is heated with hot concentrated KMnO4? So remember, this is strong oxidation. First thing, I mean, let me let me draw this. It's a double bond carbon, and the carbon has, this carbon has 1H. This carbon has 1H. This carbon also has 1H. So both of them have, and then there is CH2. On the right, there's another CH2, and then there is an OH, and on the left side, there is CH2, CH3, right? So first thing, is the alcohol primary, secondary, or what, tertiary?
Primary.
So that's a primary. So that means this carbon atom will turn into a carboxylic acid. What happens to the double bond? We did double bonds, I think yesterday. I told you that what happens is that a double bond is going to strong oxidation, double bond is going to completely break. And there are three scenarios. Either the double bond has no carbon chains, it's got one carbon chain, it turns into carboxylic acid. If it's got two carbon chains, it's going to turn into a ketone. So, so the double bond is going to completely break, right? So this carbon over here has one carbon chain. So what will it turn into? I mean, this, everything else remains the same.
A carboxylic acid.
So this one will turn into a carboxylic acid. What about the other side? The double bond. So this carbon also turns into, the right side, the primary alcohol turns into a carboxylic acid, right? So what about these two carbon atoms? What will they turn into? The double bond has broken. So both of them have one carbon chains, right? So both of them will turn into carboxylic acids. So both of these carbon atoms will eventually turn into carboxylic acids. The primary alcohol, this one would also turn into carboxylic acid because that's a primary alcohol. So remember, if you've got the carbon that was making the double bond had one carbon chain, it turns into a carboxylic acid. So we just did that we broke the double bond, this carbon atom, and we had this carbon atom. The double bond got broken in the middle, both carbon atoms, they turned into carboxylic acid. Is that clear?
Yes, sir.
And the alcohol, the primary alcohol on the right side, it turned into a carboxylic acid as well. So which one is the correct option? That's probably going to be the last one, right? It's D. Is it D? Yes. CH3, CH2, COOH. And this is COH, CH2, COH. So it's COH, CH2, COH on the right side as well. So is this clear?
Yeah.
Yes.
So then it says that in its reaction with sodium, 1 mole of a compound X gives 1 mole of H2, which compound might X be. So let me just quickly add another thing about alcohols. Another reaction apart from this is that alcohols are like really terrible acids. Alcohols are extremely weak acids. What do acids do? They donate protons. They donate H+1 ions or protons. So that is what acids do. So alcohols are like really horrible acids. They're such bad acids. I mean, you can't be treated. I mean, they almost no acid reactions. No acid reactions or properties. I mean, there's such bad acids, you can't even call them acids. And they don't undergo even any acid reaction. Their ionization is even lesser than water. Even less than water. Water produces, like if you have pure water, in pure water, the acid concentration is this much. I mean, that's almost non-existent. It's like very minuscule. So acids produce H plus ions that have a lower quantity even than water. And this is what the acid would do. It's if you have an acid, sorry, if you have an alcohol, it will very weakly ionize and the H at the end would be lost. And Na+1 would be formed, right? So anyways, you've got sorry, why did Na+1 come in? Not Na+1, H+1. So the OH group over here, it dissociates. But they're like really terrible acids. So hardly any ionization happens. Is that clear? So
Yes.
so you can't even call them acids. The only thing is they undergo one reaction, which is a typical acid reaction. So they only react with very reactive metals, very reactive group 1 metals like Na. So alcohols will produce, like if you react it with Na, they're going to produce a salt plus H2 gas. So this is what the alcohol would do. But this reaction only happens with extremely reactive. So the H in the acid will get displaced by sodium ions. And as a result, bubbles of H2 gas would be produced. Since only one H got displaced, so it's going to be half H2. This is how all acids react. Like HCl, which is a strong acid, if you react it with Na, the H gets displaced by Na. And so it's a typical acid reaction. Although this is a redox reaction, it's not an acid-base reaction, but acids do react with reactive metals. So alcohols will do that. And in the case of alcohols, it's going to be a really slow reaction. So it's going to be really slow and very slight effervescence. So Na usually reacts with things very vigorously. So that's kind of a test for identifying alcohols as well. Like Na reacts with everything very quickly, but with alcohols, it reacts very slowly. So that's pretty much it. The only one reaction for alcohols. Is that clear?
Yes. Yes, sir.
So coming back to the question, he's saying that, and then there's who reacts with Na. I'm also going to add carboxylic acids. Now, carboxylic acids are your typical acids. So carboxylic acids are typical acids, but the only problem is they're weaker. Like compared to the other ones, they're kind of weak. So carboxylic acids undergo all acid reactions. What are these all acid reactions? If you have a carboxylic acid, it's going to react with metals. Like if it reacts with sodium, it's going to form, the H would be lost. Sodium, it's going to take its place. It's going to form a salt plus H2 gas would be produced. So metal plus acid produces salt plus H2. Metal plus base, so it will have a reaction with the base as well. So bases are oxides and hydroxides. So it's going to form the same salt in the same way. And H2O would be produced. It will also react with weak bases like carbonates. So sodium carbonate. In that case, the same salt would be produced. It's going to be RCO-1, Na+1 plus water plus carbon dioxide. And there's another weak base, which is ammonia. So carboxylic acids would also react with that, and they're going to form ammonium salt. So the H will get replaced by NH4 plus 1. So these are some of the common acid reactions: metal plus acid, base plus acid, carbonate plus acid, and ammonia plus acid. In all cases, carboxylic acids will react. Alcohols, no reactions, just with sodium. So coming back to this question, we have this question, and the question states, who's going to produce 1 mole of H2 if 1 mole of in a reaction with sodium, 1 mole of a compound X gives 1 mole of H2. So reaction is with sodium. So the first one, will it react with sodium or not? It's an alcohol.
Yes.
So it will react. And if it reacts, so it's going to be CH3, CH2, CH2, I think there are 3 CH2s. And then O minus 1, Na plus 1 would be formed. And how many H's would be displaced? Just one, right? So it's going to produce half H2 gas, right? Is this clear?
Yeah. Yeah.
So he's saying 1 mole of H2 should be produced. This only produces half H2. This alcohol will also react. So only 1 H would be displaced, and this would become O minus 1, and this one would become Na plus 1. Since only 1 H2, so half H2 would be produced as well, right? Carboxylic acid, again, only one of the carboxylic acid H would be displaced. So half H2 would be produced. What about this one? It's this alcohol and this carboxylic acid OH. Both of them would react. So there's going to be an Na over here. Like if I draw the product molecule would look like this. It's CH. The bracket, it's going to be O minus 1, Na plus 1. And then you have CO minus 1 and Na plus 1. So how many H2 molecules, H atoms got displaced? 2 of them, right?
One mole. There are 2. Yeah. 2 hydrogen.
So together they're going to produce 1 mole of H2. So is this clear?
Yes.
So the next is you've got again, there's a reaction with potassium dichromate, and then there's Felling's reagent as well. So he's saying which compound could be Z? What is Z? He's saying when the apparatus below was used with compound Z, a brick red precipitate formed in the right hand tube. A brick red precipitate. So first one, is this a primary, secondary, or tertiary alcohol? What type of alcohol is this?
Primary.
Tertiary.
Secondary.
This is a secondary alcohol because
Secondary. Yeah.
there's carbon with H and it's got an OH, right? And there are 2 CH3s, one on the right side and one on the left side, right? So that's a secondary alcohol. What do secondary alcohols turn into if you oxidize them?
Ketones.
So they'll turn into ketones, and ketones don't undergo oxidation. So if the ketone evaporates, it's going to go to the Felling's reagent. So as I saw this one, ketones don't undergo oxidation. Aldehydes do, but not ketones. So no brick red precipitate, nothing in this case. Let's just
So what
quickly.
do aldehydes oxidize to?
Aldehydes get oxidized to carboxylic acids.
Yeah. Okay.
Actually, they get oxidized to carboxylic acids. Then the next one is, this is a primary alcohol. Is this a primary alcohol?
Yes.
Yes.
So primary alcohols will turn into aldehydes. And I told you that if you allow, the aldehyde would evaporate very quickly because so the aldehyde would evaporate and it will go over there, and because you're not refluxing it. So you don't have so aldehydes don't form hydrogen bonds, they would evaporate very quickly. They would immediately come out of the container and they would meet Felling's reagent and they'll get oxidized back and they'll turn into carboxylic acid. So in both cases, this is going to work. It's going to give you a brick red precipitate at this point. And this is also a primary alcohol. Remember, carbon with 3 H's, that's also primary alcohol. It works exactly the same way. Is this clear?
Yeah. Yes, sir.
So that will turn into an aldehyde as well, and that will then turn into a carboxylic acid. So the first one is the only one that is not going to work. The second 2 and 3 are correct. So let's continue tomorrow. I'll just just assuming, I'll just tell you, I'll just change the format a bit. What we'll do is, I mean, we're doing alcohol questions, so we'll just do alcohol questions. I'll write down the notes, the way I just wrote down over here. So instead of actually focusing on the content, we'll focus on the past paper questions. I'll write everything that is needed. So our notes will get built this way as well. But the focus would be more on past paper questions. So we'll try and do more alcohol related questions, then we'll do some carbonyl related questions. And I'm going to explain everything which we come across. Is that clear?
Yes, sir. That's a better idea.
ठीक है.
Thank you.
चलें ठीक है.
Right, just down there.
Okay, take care.